Hello, I am Asko Ristolainen. I'm from Tallinn University of Technology from the Center for Biorobotics, and in this short presentation I will be talking about the effects of a novel underwater robot on fish behavior and welfare in sea cages. Shortly about our team. The Center for Biorobotics at Taltech is now just over 10 years old. In the lab, we are developing different bio-inspired robots, but also bio-inspired sensing technologies that we use in different aquatic environments. In this study, we try to address the industry need for better monitoring. Monitoring in sea cages is important for fish wellness and health, but also the cage cleanness and its integrity. Currently, the standard for monitoring sea cages is using human divers or commercial remotely operated underwater vehicles. Both of these solutions are costly and are stressful for the fish. Also, propeller-based underwater vehicles can't operate near cables or ropes, as the propellers might get tangled and can cause damage to the infrastructure and to the robots itself. As a solution, we propose to use a bio-inspired robot called UCAT. We predict that smaller, lower-cost, slow-moving robot with non-traditional method of locomotion would cause less stress to the fish than a diver or a traditional propeller-driven robot. This would allow cage inspection and fish wellness observation at lower cost and with smaller impact to the fish population. The UCAT that you can see on the upper images uses a bio-inspired method of locomotion by using 4 soft fins. It is highly maneuverable and can navigate close to objects without disturbing sediments or causing damage. The initial purpose of using UCAT was the exploration of shipwrecks and archaeological sites, but has found applications also elsewhere. The study showed that the fish remained calmer and closer distance to UCAT compared to the traditional commercial robot and diver. It's not very clear, was it because of the sound, size, color, speed, or method of locomotion that causes this difference. Also, the study found that both robots caused less stress to the fish than the diver, even with the divers remaining still and the robots moving. About the experiments themselves, we used interface facilities at Korseneset, Norway, where we used a sea cage that contained about 190,000 salmon and cleaner fish. The average weight of salmon in this cage was about 330 grams with the average length of 28 centimeters. In the experiments, we moved the robot back and forth into the sea cage up to 5 meters where the fish were schooling. The onboard cameras of the robots was used to take footage of the fishes, and also diver used its own camera to record the surrounding fish. At the bottom of the cage, a stationary camera was used to track the motion of the robots, the diver, and also the fishes. Later on, the video was analyzed to track the behavior of the fish. We used fish tailbeat frequency and distance between the fish and robot or diver as evaluation metrics. A sample size of 50 fish was tracked for each run. There are various end users to our bio-inspired solution. First of all, the aquaculture farmers can use bio-inspired robots to improve monitoring of health, welfare and behavior of the fish in the sea cages. Also, they can use our robot, for example, to monitor the integrity and the conditions in the sea cages. Secondly, the technology producers can improve the knowledge about new technological solutions for monitoring fish in the sea cages. Thirdly, aquaculture researchers can use our solution to monitor the fish with minimal disturbance to better understand their behavior. And fourthly, aquaculture marketing can use bio-inspired robots to monitor fish in sea cages to allow for improved welfare of the fish, therefore helping to improve the public perception of aquaculture. Currently, the robot UCAT is at TRL level 6, meaning that it has been demonstrated in relevant environments. The IP of the robot belongs to the university. At the moment, we are using the UCAT on different fieldwork applications in research, but also teaching robotics courses at Tallinn. At the moment, we are missing a development in the software part that can allow the end users to intuitively control the robot. Therefore, some more software development is needed for the robot. Thank you for your attention. If you have any more questions regarding the robot UCAT or its applications, or if you would like to apply the robot in your field, please feel free to contact us. Thank you.